Testing, testing. I had a bath, I had a shave, and I'm done with breakfast, so let's resume. In the previous video, we've managed to make the deck module working. We have the tests for it, and now we can draw the cards from the deck for the Ladakh game. We've also implemented the Xorosho random number generator. In fact, the most important work that we did was in this build file. We also generated this install CPP dependencies file, which can automatically take an array of records where one of the record fields is the URL and one of the fields is the commit. And this will install all the dependencies in the CPP libs folder. So we'll be using this particular random number generator for our random number generation needs on the host. And the next step is to just simply start to work on the game. And that's actually going to be pretty easy. The game itself, we just copy paste this. Yeah, great. So we have the actions, we have the pot, we have the community card, we have the PL card, player card, raises left, is buttons, first move, player turn, messages, showdown, player action, community card is. Okay, so I guess we kind of need to study it for a bit to figure out what's going on. Here are the game nodes, random action. Let's see. Array from list. So it pushes the actions into a list. Core CUDA random shuffle. Okay, that's going to have to change. Well, let's take a look. Random shuffle. Random and shuffle. Okay, sorry about that. This is just the Knut shuffle, and this isn't specific to CUDA. This int range, I think that's also not specific to core CUDA. As long as we have the proper prototype instance, it should be able to use this. And the SA list, I wonder how that is implemented. I mean, if we look at one of the compiled examples, say list, a static array list, so it has the length. So it has push. This has pop. It also has unsafe set length. And when indexing it, yeah, the assert is done over here. Okay, I see. So yeah, maybe we didn't need to add the assert in. Yeah, we didn't need to add the assert in set, but actually I don't think we have the set here. But we can also remove the assert in, let's see, index set. Index set. Here we have the assert index must be range. Well, let's get rid of these asserts, since there should be in the core library. And we have to make sure that they are actually implemented in the core library. Let's see. The core library. Okay, let me get rid of these. Okay, well, what exactly was this? Never mind, never mind. Let's just ignore this. We have to take a look at the core library. Static array. Oh, it returns a reference to the element. Oh, so that's how it works. I see. So yeah, this can, because it returns a reference, this can be reused for both setting and getting. Yeah, this is nice. Okay, I like this. We just have to make sure that the asserts are turned on. Static array list. I mean, all of these operations have the asserts. You know, C++ has a lot of low-level functionality that really shouldn't be used in everyday code. But, you know, it's not really that bad once you get... I mean, I won't say once you get used to it, but once you're actually using it from a language like Spiral. What is this length underscore? Okay, never mind that. Oh yeah, it's probably length underscore because we have this length field here. I mean, we actually don't, but that's probably my reasoning for doing it like this. Okay, never mind that. Let's move on. So we've confirmed that the static arrays all have asserts in the core library, so we don't need to also put them in Spiral code. So this is Control K, Shift Enter. Okay, now I got rid of that. And pin this. So this will work. In fact, I do think this is an elegant way of doing it. Okay, so we can sample random actions, put call, static array, initialize. Yeah, these are all the state transitions that we need. It's going to Yeah, all of this is fine. But now comes the hard part. Because if you look at the DAC's model CFR, and that already uses the tabular CFR implementation, and the tabular CFR implementation has been implemented for the GPU here. And yeah, make no mistake, this is pretty complicated code because we're kind of applying all of these IDs. You know, if it wasn't done in Spiral, this would be a nightmare. Imagine having to do this in raw C++ without tensors and having to do manual indexing. Yeah, it would be a nightmare, definitely. And it's really unfortunate that all of this code is pretty much useless to us, unless maybe in the future we might use it as a reference. But as far as actually using it to run the players, it's useless. I put so much effort into it, and the only thing that I got out was programming skills. I really wish that I could make my own project and actually make money off it. I think that's pretty much the dream for every independent software engineer. That the thing they are working on becomes the thing that sustains them. It doesn't matter how rich or poor one is. It doesn't matter how young or old. It doesn't matter how smart or stupid. The only thing that matters is if one has the will to make a single step forward. It doesn't matter how long one's path one is. When I dream of making millions, I cannot forget that the millions aren't really what really matters. The future isn't what matters. The singularity doesn't matter. What matters is this session that we are doing right now. Step by step, we'll go into the future that way. And if my power isn't enough to get me where I want, then so be it. I'm only human. Okay, so what do we do? What do we do? I mean, what else can we do? We got to do the CFR implementation. And what do we do in CFR? This is for training. It's gonna be it. UI game state. Basically, we come to go over all of this and think about it from the top. We need to think about whether it's right. State to internal. One thing that will make our job easier this time around, since we are using both C++ on the host and the device, we won't need to pick all the data like we did when we were transferring it from the Python side. It's going to make things easier and more efficient. Oh yeah, this is the interpreter. This is the play loop. We have to handle all the cases, push messages. The messages, those are for the UI. Damn, it's a lot of work, but I guess we'll get through it one by one. As I said, the future doesn't matter. I'm kind of pressured to make money, but just forget about it. So what if my parents make some comments that I need to work harder? Like, I've just made like 10 yearly salaries in Croatia. I deserve a vacation. The only problem is that maybe in a few years we might have another 2008 style crash. So who knows how things will go. Maybe there will be a big civil war in the US. So it kind of like there is pressure to just make the money now. But it's pretty much always like that. There's always some kind of storm brewing in the background when it comes to financial markets, and people get wiped out, and life goes on. Honestly, it won't be that bad if there's a huge crash because huge crashes are huge trading opportunities. Generally, when the market goes down 50%, there is a very strong mean reversion effect. So you can use a momentum method to just ride it on the way up. I think, okay, if the market will crash, like in a couple of months, and it turns out the Standard Poor's like is down 50% or something like that, I know that the rebound is going to be a huge trading opportunity. So I'd probably actually drop whatever I'm doing and look into how to actually trade for real, because it would simply be such an amazing opportunity, and I'd want to be ready. I could probably take a couple of months to prepare for the upturn. And even if I didn't, there's still a very simple trading method where you just buy a third, then wait 2 weeks to see if the market goes up. If it doesn't, you cannot sell, then wait 2 weeks and then try again. And then you just buy on the way up. Actually, in case you're wondering what I'm talking about, actually have on my GitHub I have let's see. Uh, okay, let me show you the trading journal. I mean, it's public. No, where is that repo? Uh, Browse, open. Wait, maybe. Yeah, I think open on remote, open file on remote, and I can since I have the money, I put a bunch of resources here, and I even have a method on how I trade like the markets. The method that I did here, what happened is that I actually went along after the Trump panic, and I even put my money in like the strongest sector in the whole market, and I held it in a bull market. And the end result is that I still didn't make any money, so which is extremely annoying. So right now I'm not in the market at all. Before I come up with a better method to trade in bull markets, but in huge momentum rallies like you get from bear market lows, pretty much everything will go up hugely. So the method that I was using is probably fine. Sorry, let me go back to programming. Okay, in case you're wondering, I used to be a trader from 2007 to 2014. I wrote as much in the journal. I think probably the most important thing that I learned back then, and not that I learned back then, but that I learned just this year in 2025, is that it's impossible to actually look at a chart and have a system in mind for how one would trade the market, and then get an accurate picture of how that system would have performed, which is actually very surprising to me. If you listen to interviews by, for example, Peter Brand, he suggests that we look at the charts and maybe test things out in your mind. But wow, don't fucking do that. Seriously, don't. I've been trading like 7 years, and it's gotten me absolutely nowhere. I understand now that if I want to get anywhere in the stock market, I need to actually backtest my ideas and use the machines to help me think. And exactly the same thing applies to poker. Once you have some kind of system, maybe you can trade it in a discretionary manner, but otherwise I wouldn't recommend it. Excuse me. So what do we do here? I mean, we have to implement the play loop. Okay, whatever. I just don't feel any affinity for this old code anymore. Like, I put a great amount of thought into it back then, but who cares about all of that now? I guess I'm going to have to go do it from the top. So let's start with a play loop. I mean, let's do a train loop, whatever. And then, okay, shift enter. I mean, here's the train loop. I was wondering where that is. Okay, shift enter. And so it takes in the CVR model, internal state, player ID, node. Oh my god. This train controls whether to run the update trace, adjusting path probabilities, or the average or the current strategy is used for evaluation. So much work went into this, and it's so useless. I learned so much, but none of it is. I cannot cash in any of this. It's such a struggle. Yeah, this kind of this my programming journey is kind of like a replay of my trading journey. I really, when I was a trader, I really struggled to push my brain and to try and understand the markets, but I only got so far. And also, as a programmer now I struggle to really understand intelligence, and I've only gotten so far. I completely didn't meet my goals at all. So I won't have those kinds of goals anymore. I'm simply going to grind at it. I'm simply going to work at it. What's even the point of understanding anything if that effort won't be rewarded? The only thing that I've gotten are my programming skills and my understanding of machine rationality. And when I say machine rationality, I mean the actual machine rationality where you have a inference algorithm and a model. But modern day rationalists do is they don't have a um, inference algorithm and a model, but they do have like a premise and an absurdity. As an example of that, take a look at the paperclipper example. The paperclipper is kind of a story of a super intelligent AI which converts the whole universe into paperclips somehow, which is kind of a very stupid premise because it kind of presumes that humans would actually be able to understand how a god would act. So that's already a loose premise, and then you have an absurdity in that the god would, convert the whole universe into something like paperclips. And to them, this is a thought experiment that kind of illuminates how dangerous artificial general intelligence is. But to me, it just looks like they are really fucking stupid. Unless you have an exact model of intelligence and an exact inference algorithm for how to actually do reasoning with that model, then you're just spouting shit. It's really important to understand your own limitations. Yeah, I mean, right now you're just looking at me talking philosophy and scrolling up and down. What the hell? What the hell is all this? For fuck's sake, it's pretty complex. Thinking towards my probabilities. Too much reasoning effort went into this, and now it's no use. I mean, it's not going to be of use on the host until later when we do the Hopewell dictionary on the GPU, assuming we manage to prove it on the host, which we most likely will. Then I don't know if this will be useful either. But what I do like is the overall architecture of all of this. Like I like how instead of like a monadic construction, we have an interpreter. That does make things a lot easier. Okay, I'm going to pause here so I can think about it, and then once I'm ready to start coding, or maybe once I've managed to gather some momentum, then I'll resume the recording. See you in a flash. Welcome back, dear viewers. I've yesterday had the chance to think about things, and I've actually realized why in some of the previous videos I was returning references when indexing into a layout type. The main reason for that was that the layout type might have something like a static array, like this thing here, and we want to be able to mutate that array. And if indexing into a layout type returns a value type, then it would copy the entire array. So we don't want that. We want reference semantics instead of value semantics where appropriate. I had the time to think about how we'll fix this, and there is no other choice. We are simply going to have to add a new feature to the language. I thought about maybe adding something like a new layout type that only returns references when it's indexed into actually That might be a choice. In fact, originally, yesterday when I was considering this idea, I thought that we could have something like, let's say, something like a stack refs type to replace the stack mutable here. But I also imagined that it would only hold references inside. That it would hold references to other types inside its structure. But we could also have it just hold the value types and then just return references when it's indexed into. That might be easier returning uh, than returning. Than adding a whole new operator to the language that returns a reference when it's indexed into. Uh, hmm. Do you maybe want just that? Um, I mean, we also do want maybe then we could have a heap refs type. Okay, this is no, okay. This is an avenue that I haven't really considered. I only considered the avenue where maybe the heat, maybe the stack ref holds references. Let me pause here so I can think about it more. Yeah, the simplest solution is usually the best one. Let's go with stack refs and heap refs. We'll just add two new layout types to the language. Yeah, this is the correct way. I mean, I really like being able to um, index into an layout type and then having a reference be returned. That's not a very that kind of makes it unclear how a particular type should be used. When you have something like a heap refs or a stack refs type, you'll immediately know that indexing into it returns a reference, and that any other places that index into it will mutate the same reference. Um, let's see. Uh, meet. Yeah, where was the code generator for it? Yeah, I think. Mhm. Okay, let me add a bookmark here, and then I control click, and these are the layout types. And we'll add heap refs and stack refs. And then, as you can see now, we have some yellow here. And this is saying incomplete path matches on this expression. For example, heap rex. Yeah. So, oops, not this, but let's go with stack refs and heap refs. Refs. Uh, yeah, and now this will return a reference. Wait, why the hell is this heap refs? Oops, I meant to do this. Heap refs. Yeah, now this will result in a reference indexing behavior. So let's see. As you can see, we have a bunch of warnings that we need to go over. So what do we do? Okay. This is going to be stack refs, and heap refs. And we're going to how to create two new functions to actually co-generate the layout for them. Okay, what is this is heap? Okay. 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 So this is going to be stack refs, and this is going to be let's see, heap refs, heap refs, and this is going to be true. And now we should generate those types. Okay, I see some yellow over here on the sidebar, so we just have to go through them. Stack refs, stack uh, refs, stack refs, heap refs, heap refs, heap refs. And you can see how easy it is to actually work on a programming language in F Sharp. Imagine if we were doing this in Python, especially like after you come back, after a year of not working on it. Good luck, making any of these changes. Uh, Title layout. What? Stack immutable layout types. What? The good and backend doesn't support stack. I mean, it does. Wait, what is this title layout? I mean, okay, it's not pattern matching on a type, and it's taking data. Okay, so it's getting the arguments. What? Okay, this is very weird. Like, if this case doesn't even exist, then how is it possible that stack immutable types are even created? Like, is it maybe created somewhere else? Like maybe this particular case is also handled in a different place. Oh yeah. So yeah, it creates it like this here. Stacking it tag. I mean, why does it have to be like this? Oh yeah. The reason why is because it's by default it's printed as a reference, and all the value types when generated by the Spiral compiler are printed like uninitialized types, and then they get initialized on the very next line. But with references, we cannot do that because references because the C++ compiler would complain that the references cannot be uh, uninitialized, which makes sense. Let's just put in a bookmark here. Okay, not here. So this thing, I mean, this error is not correct. the CUDA backend handles error. They should never as expressions. Okay, and that's going to be handles stack refs, heap refs. Wait, no, actually, I don't think this is. Mm, okay, when it comes to heap refs, I think it can generate them as an expression. That shouldn't be a problem. So we're just going to copy this and heap refs, heap refs. This is going to be heap refs. Okay, this should do it. Now let's see. If I go over here, um, okay, or let's see, or heap or stack refs. To layout refs. Yeah, this should be okay. Making a language isn't such a huge deal. You just have to make sure that all the operations compose together properly. Heap mutable, stack mutable, heap. Uh, let's do heap refs here. Stack refs here. This is just for setting the values of it. That shouldn't cause any trouble. And yeah, we've done everything that we needed in this code generator, I think. So it's an easy job to extend it here. But now if you look, we have a bunch of problems here. Incomplete pattern matches, heap refs. I mean, this is the C code generator. I don't really want to support anything. And but yeah. I mean, it doesn't have the C++ reference types. So, but what can we do? We can't do anything here. Stack refs or heap. Item layout, refs, refs. Mexico. Where was that thing that I? Then let's see. I'm going to copy this. Also, I'm going to place a bookmark just in case we run into the same issue again. Um, we'll just copy paste this here. I mean, this isn't really a compiler error. Think into okay. Let me listen to music. let me pause the music here. Okay, this is a bit weird. Why did I implement this like so? Like, why is it not indexing by key? Like in here, tile layout index by key. Do you record? No, wait. I think this is supposed to. I see. This isn't key-based indexing. Rather, the reason why it's doing it like this is so that the common sub-expression elimination gets rid of the indexing when it's applied to the heap type. And this, I'm not sure whether this would have done the right. I mean, yeah, it would have done the right thing when combined with reference indexing. Okay, so stack refs. I mean, it's just a small optimization site so that generated code is nicer. Um, okay, layout to heap, layout to heap mutable, layout to stack mutable. Okay, so it's a good thing that we got this here because it wouldn't have warned me that there was a state that there was a missing case that we needed to take care of. Mm, I wonder if we could somehow design this a bit better. I don't really want to add an extra field to the operations because the the operations were intended to be as to be just like an enum, and when you define a whole union type without any fields, that's called the generate union type, and it can be compiled more efficiently under the hood. So okay, I guess we'll just lay out to stack refs layout to heap refs. Stack refs heap refs. Oops, heap refs. Uh, oh. Now we have to add these two new ops. So let me copy them. Let's go here. Not bad. Now let's go back to the partial evaluator. And now as you can see, it recognizes these ops. So I mean, is this all that's needed? Like, where is it checking? Where is it checking the layout set? Mutable set keep mute layout index tile layout mutable set. And if we search for that in the partial evaluator, so this is over here. Yeah. This is let's what did I do? Yeah. Okay. So let's do. Hmm, wonder if I could somehow make it. I just want to make this a bit nicer so that it actually gives me a warning if I screw something up in the future. This is going to be. This is simply going to be. Let's say heap. And damn it. Um, let's make this layout. Then we'll match it. Uh, s- this is going to be. The, yeah, now it's giving us an error. I mean, a warning. Stack refs. Heap refs. And really, these two should only be generated in the C++ backend. But never mind. I won't bother checking for that in the partial evaluator. Mm, yeah, I'm not really happy with how this is handled exactly. Layout index, by layout, layout, rewrite. Yeah, what exactly is this doing? This is applying a layout type. Time layout index by key. Okay. Mutable set. Okay, that takes care of that. And the only problem is that we still haven't done everything that we needed, even though we have no warnings. For example, in the inference module, we have to somehow be able to actually construct this new layout type. So, okay, in the infer, if we go at the bottom, uh, okay, here we have the stack mute. We have to add these two types, stack refs, heap refs. Oops. So now this will be a base type, and type inferencer will be able to fetch it. What exactly do we have to do other than that? Well, I think maybe in the core library we actually need a way of constructing this. Hmm, yeah, let's build and compile this. Added two new layout types to the language. Let me also add it to the change log. Added the stack refs and heap refs layout types to the language. Indexing into them will generate says in the resulting code works only in the C++ backend. And I'm going to have to add an entry in the manual on them. Mm, Top-down segment, stack mutual layout types. Um, Stack refs, refs, yeah. Added it. The same as what? Immutable and stack without layout types, but indexing into them generates references in the resulting code. Yeah, not bad. And I need to do. I'm going to have to produce some code examples, but we'll leave that after we do the tests. Okay, not bad. I mean, in fact, it might not be bad if we added even another layout type that only holds references, but it's not that important. Hopefully, the C++ compiler will optimize that away. I mean, those copies away. So, let's turn on the music, and we're going to test things out. Okay, here we have our first error, and the heap refs type isn't really supposed to be like this. Um, okay, let's take a look in the code generator. Let's close this. This is okay. See, this is the YAML library. Wait. For fuck's sake, I forgot how to do the bookmarks. Is it like this? Toggle, Control K, Control J. Yeah. Okay. Now let's see where the stack mutable is. Wait, not here. I'm actually not really checking this at all in the partial evaluator. Um, Heap refs. Oh yeah, let's go into the type inferencer again, and we got to make sure that the table set. Where is the layout set? And layout set must be annotated. Okay. Raw heap immutable set. That is being checked. Where is it generating them? Yeah. This is just their indexing. But what about the types themselves? Oh yeah, that should be in by type, yeah, like this. And it should be, yeah, on this. And when it comes to the heap types, I wonder I missed anything else? Let's see. No, not the whole world. World, I mean. You heap, you stack. Okay, I got this right. It's wrapped in a shared pointer. Yeah, okay, let's try building it again. I'm just wondering, instead of initializing the heap types like this, maybe we could also make them so they are statements. Who cares? This is good enough. Let's just test the mutable setters. What I'm thinking right now is when there is only like when this type only has a single field, maybe we should just generate it as a regular reference. It would be a bit of special behavior, but maybe it would help when it comes to. Mm, I don't know. I mean, yeah, whatever. Whatever. We can in fact leave the reference module in core CUDA as it is. Like, it's not like we need a single language feature for everything. The stack reference type, the stack refs layout type is here for a different reason. As usual, it will take a while for the extension to be live on the VS Code marketplace. So we're just going to work in the extension code in the extension host until then. Obviously, for some of these later examples, we're going to, I mean, in order for them to actually work, they're going to have to use the stack refs types and the heap refs types where they were previously using stack mute. I'm probably not even going to bother fixing this. Instead, oh yeah, maybe this is everything that we had to change. I guess that was easy. I mean, okay, this is just from the deck. We probably had to change some things in no limit hold'em, place VR, stack mutal. So VR. Yeah, not bad. I think this is a good solution to our problems of indexing into references. Well, let me think. What do we have to do next? In, let's say, in train counterfactual regret. Yeah, we probably need this internal state, or at least some of it. We probably need player type, deck messages, RNG, rewards. Yeah, what exactly was the plan? Yeah, the plan was to deal with the reference indexing issue, because I realized that we in fact needed reference indexing into layout types which we had before. So that has now been fixed, the language has been extended, and the next thing that I have to figure out is how dictionaries work on C++. I need to test out how their comparison function works, how do I use it in Spiral. And after we have that, that's the most important thing. After we understand how dictionaries work in C++, we are going to use them to implement a enumerative counterfactual regret algorithm. We'll also use it for the Monte Carlo one. This is a good time to pause, and after that, maybe in the next video we'll actually figure out how C++ dictionaries work. See you soon.